So page 45, letter A first, which is 1 over x plus 2 times 2x minus 1. Okay. Okay. So we want to do this problem. So do you remember what's the first step?
We have to factor.
Factor. But it is already factor though.
A and B.
Yeah, exactly. So you need to find out what are the denominator factor, like Haley just mentioned. What are the denominator factor? So as you see here, how can I
X
see?
plus 2.
Yeah, x plus 2 and then 2x minus 1. So you can rewrite this.
2x minus 1.
A over.
A over x plus 2.
Mm-hmm.
And B over 2x minus 1.
Yes. Okay. Now, so it became the rational equation. So what's the least common denominator?
X.
So LCD becomes, as you say, x plus 2 times 2x minus 1, right?
Mm-hmm.
So you multiply LCD everything here. Okay, then, so this first term becomes, so this and this all canceled out, right? So 1 just left. Make sense? Haley?
Yeah.
Makes sense, right? Okay,
Yeah.
then now, so this term becomes, this canceled out, so become a times 2x minus 1. Now this one, as you see, this canceled out, so become plus bx plus 2 then. Okay, now, so from here, so we're gonna find out which value makes that expression 0. So easier way is just to make 2x minus 1 equal to 0. So x plus 2 equal to 0. Okay, if you solve it, then we got minus 2, then x become negative 2, that's 1. And here you add 1. So 2x equal to 1 divided by 2. So x become 1 over 2. So those are key value to find a and b basically. So now I'm gonna just input x equals negative 2. So here x equal negative 2. Then this will be 0. Yes, I'm gonna show you. So 1 equal to a times 2 times negative 2 minus 1 plus b negative 2 plus 2. So as you see, this becomes 0. So 1 equal to, so negative 4, negative 5. So negative 5a plus 0b. So we don't need it basically. So I'm going to just erase it. Okay. Then divide by negative 5. Therefore, we got a equal to negative 105. So that's it. And now you don't replace a equal negative 1 over 5 into this equation yet. Instead, now you are putting x equal 1 over 2 into here. So 1 equal to a times 2 times 1 over 2 minus 1 plus b 1 over 2 plus 2. So as you see, this is become 1 minus 1, so it's gone. So 1 equal to, so what's the 1 over 2 plus 2? So I can make 1 over 2 plus 2 over 1. So LCD become 2, so 1 over 2 plus 4 over 2, so become 5 over 2. Okay, so plus 5 over 2b. Now, when you just get rid of this one, divide by 5 over 2, then b becomes 1 divided by 5 over 2. So this become 1 multiply 2 over 5 to become 2 over 5. So we found a equal negative 1/5, b equal 2/5 here. So we replace here to this equation. So I can rewrite this. So this is the negative 105. So you can rewrite this negative 105, and then b 205. So that will be our partial fraction for this complex fraction basically. Okay. Any questions so far? Hello, Lala.
Hi, Professor.
Okay, then let's do one more questions. So here, so see here, see x minus 5 over x squared minus 3x. Okay. Now, unlike other questions, this one is not factored yet. So, oh, do you see my screen?
No.
No. Okay. So this question here, so x minus 5 over x squared minus 3x. So unlike other question, it is not factored yet. So the first step, you need to factor on denominator. Okay. So let's make a denominator factor. Then this becomes x minus 5 over x minus 3. Good. Basically x squared and then 3x, they share common factor x. So after factoring that, it come out x times x minus 3. So this one you can rewrite. So a over x plus b over x minus 3. Because we have two factor on denominator, this and this. That's the reason we can rewrite like that. Now the same thing, we are multiplying LCD. So this case, LCD becomes x times x minus 3. So you multiply everything, x minus 3. Then this becomes, so x minus 3 times x minus 5 over x minus 3 equal to x minus 3 times a over x plus x minus 3 times b over x minus 3. Okay. Now we canceled out all this common factor between numerator and denominator. Then this all is gone, x is gone, x minus 3 is gone. So this becomes x minus 5 left here. They equal to a times x minus 3 plus bx. Okay. So far so good?
Mm-hmm.
Okay. And now we need to find out a and b. So you need to look at these factors. What value make each expression become 0. So set up x equal to 0, and then x minus 3 equal to 0. Then this one just x equals 0, and you combine 3 here, then x equal to 3. Good? So now we are plugging each value into this equation, then we can find a and b value. So x equals 0, then 0 minus 5 equal to a 0 minus 3 plus b times 0. So this is gone because b times 0 becomes 0. So negative 5 becomes negative 3a. So divided by negative 3, then a equal to 5 over 3. Now, go back to original question here. Don't replace 5 over 3 into a yet. So x equals 3. Then 3 minus 5 equal to a 3 minus 3 plus 5 times 3. Oh, sorry, b times 3. So as you see, this is gone. So 3 minus 3 becomes 0. So negative 2 equals 3b. So divide by 3 here. Then we got b equal to negative 2 over 3. Okay, so we got a equal 5 over 3, b equal negative 2 over 3. So we can replace to here. So a was 5 over 3, so 5 over 3. B is minus 2 over 3. So switch this to minus 2 over 3. Don't forget the parentheses here. So that will be our partial fraction for this composite fraction. Any questions? Okay, then I'm gonna just give you a few practice problems. So here. So I'm gonna make it so I don't know the answer either anyway. So what about this one? Okay, so practice those two problems, okay? Did you find the partial fraction for number 1?
Yes,
Okay, so what did you get?
I got a equals to 5 over 3 and b equals to negative 3 over 2.
Because of 5 over 3 x minus 4, and then plus
No, negative.
or negative. Okay, and then second one is
No, no, the second one is negative. B is negative.
the first one is positive then.
Yeah,
Okay, and then minus
3/2 multiply with x negative 2. I didn't know. Should I multiply or just leave it the way it is?
That's fine. So, what do you think, Heidi? Did you get this one too?
No, I didn't finish it.
Excuse me.
I didn't finish it yet.
Ah, okay, you didn't finish it yet. Okay. All right, then I'm gonna give you a few more minutes. So, finish until number 2.
I got 5/2. I don't know.
5/2. Okay, let me check. So another answer become 5/2.
I don't know.
What about second one?
23, -3/2.
Okay, so we can double check. Okay, we can double check really soon. So, I think Osama gave
It's-
me 5 over
It is
3
over 2. Yeah, yeah.
over
5
2.
over 2. Yeah.
Okay, so then I'm gonna just extract this one. So please double check you get this answer. And then I'm gonna give a few more minutes so you can finish number 2 as well. Okay,
For
so
number
let's go
2, I
over.
got -7/5 plus 7/5 parenthesis x minus 5.
What did you get the answer?
-7/5.
Over 5.
Yeah, plus 5 plus 7/5. Sorry, 7/5.
I mean, 7 over 5 is what here?
X
X. Okay, so negative 7 over 5 x and plus 5 over x minus 5,
7.
like this.
The 5, you can erase the 5. 7/5.
So 7 over 5.
Yeah. Over 5x plus 7/5.
Another 7 over 5.
And the other 5 on the outside of the parentheses. That's what I get. I'm not sure.
Okay. Anyways, let's review both questions. Okay, so here, so number 1 first. So we have x plus 1 over x minus 4 times x minus 2. Okay. So this one case, we have a 2 factor on denominator, which are x minus 4 and x minus 2, right?
Mhm.
Therefore, this becomes a over x minus 4 plus b over x minus 2. Okay, now we need to find LCD for this equation. Then LCD equal to x minus 4 and then x minus 2. Therefore, what do you want to do? We multiply x minus 4, x minus 2 to all this expression. Then, now this come out x minus 4, x minus 2 times x plus 1 over x minus 4, x minus 2 equal to x minus 4, x minus 2 times a over x minus 4 plus x minus 4, x minus 2 times b over x minus 2 basically. Now we just cancel out all this common factor. Then this is gone, and this is gone, and this is gone. Okay. Therefore, this becomes x plus 1 equal to a x minus 2 plus b x minus 4. So far, so good?
Mhm.
Okay. Now that we have 2 value, so we find out these 2 value, which value make each expression equal to 0. So we set up x minus 2 equal to 0 and x minus 4 equal to 0. Then you combine 2 here, so x equals 2. Combine 4 here, so x equal to 4. So those value are key value to find a and b. Okay, so x equals 2. Then 2 plus 1 equal to 8 times 2 minus 2 plus b times 2 minus 4. So this is gone because they become 0. So 3 equal to negative 2b. So divide by negative 2. Therefore, b equal to 3 over negative 2. Okay. Now, don't plug this into here. We are using this one and finding a. Okay, now x equal to 4. So 4 plus 1 equal to a 4 minus 2 plus b 4 minus 4. And this becomes 0. So 5 equal to 2a divided by 2. So a equal to 5 over 2. Okay, so I think we found correct value a and b. That's the reason your answer was 5 over 2 x minus 4 minus 3 over 2 x minus 2, right? We got the exactly same answer here. Okay, now second question, which is 7 over x squared minus 5x. So this one, now we can factor first because the fraction denominator hasn't been factored yet. So this become 7 over x times x minus 5, right? Okay, therefore it becomes a over x plus b over x minus 5. The same situation here. So we are making two value. Oh, before we do that, we find the LCD. LCD becomes x times x minus 5. So you are multiplying x minus 5 to everything. And this becomes x minus 5 times 7 over x minus 5 equal to x minus 5 times a over x plus x minus 5 times b over x minus 5 here. So we cancel out all these common factor between numerator and denominator. Then this becomes 7 equal to 8 times x minus 5 plus b times x. As you see, these two factors, the key value to find a and b. So set up them equal to 0. So x minus 5 equal to 0 and x equal to 0. Then x equal to 5 or x equal to 0 here. Okay, so x equal to 5, then 7 equal to 8 times 5 minus 5 plus 5 times b. So this is gone. So 7 equal to 5b divided by 5. So b equal to 7 over 5. Now x equals 0. And 7 equal to 8 times 0 minus 5 plus b times 0. So this is gone. So 7 equal to negative 5a. So divide by negative 5. So a equal to negative 7 over 5. Yeah, so we got actually correct answer. So the answer was 7 over 5x plus, oh, we forgot one sign here. A must be negative 7 over 5. Negative 7 over 5x plus 7 over 5 x minus 5. That would be the correct answer for this problem. Okay. So there was partial fraction anyway. So, and then I won't give you higher than this level on both exam number 2 and then final, so don't worry about that. Now we mainly talk about the rational equation, okay? So which means we are doing page like 26, chapter 3, page 26, okay? So simply think about these problems. So x over 2 plus 2 equal to 3 over 5, okay? So before we do it together, I'm gonna give you some time to think about that. So yeah, please try to do it. And then a few minutes later, we will talk together, okay? Okay, so any idea what would be the first step?
Do we subtract 2 from both sides?
Yeah, we can subtract to both sides, okay? Then this become x over 2 equal to 3 over 5 minus 2. Okay, now how can we combine these two fractions?
Professor, what if
Yeah.
we try to eliminate the denominators first by multiply all terms with 10?
So what do you mean? So we multiply 10 to every numbers, every
Yeah.
expression.
Mm-hmm.
What's the reason?
Because it's, I think so it's because 2 multiply with 5 is 10
Mhm.
denominators. So just to get rid of the denominators for all terms.
Mm, I think that's also a good idea, but I'm gonna just finish what Hades work first, and then let's go back and then what you just mentioned. Okay, so anyway, in this case, Hades, what's the common denominator for these two fraction?
10.
10?
Yeah.
Okay, then, so oh, we are finding common denominator for everything. Then this becomes, keep going.
Wouldn't it be x x times 5? I mean,
Oh,
times
so,
times
okay,
2.
5x over 10. Okay, and then
It would be wait, hold on.
6 over 10,
6 over 10. Yeah, 6 over 10.
negative 10, 20 over 1 over 10.
20 over 10. Okay. All right, and now we have all common denominator. Okay, so then 5x over 10 equal to, what's this if we combine them?
14,
So
negative 14.
negative 14 over 10. Okay. Now you basically multiply 10 over 5, right? Then x equal to negative 14 over 5. Okay. So this kind of had this kind of method here, but I'm gonna just go back to what Osama just mentioned. So in this case, we can make 2, this equal 2 over 1 and 5. So what's the LCD?
10.
10, right?
Mhm.
Since it is equation, so you are multiplying 10, everything. Then this becomes 5x plus 20
Mhm.
equal to 6. That's what you mean. And then subtract 20. Then 5x equal to negative 14 and divide by 5. So x equal negative 14 over 5. Okay. So we get actually exactly same answer. So, I mean, it is up to you which method you are using, but I prefer using LCD method more because you can get rid of all the denominator and then make as integer type of equation. Okay. So what about this then? Okay. So 3x plus 1 over x minus 2 plus 2 equal to 9 over x minus 2. Okay. So same thing. So I'm going to give you a few minutes. Think about that. So one hint is you may think about the LCD method, since that's a little bit easier compared to other method. Or you can find maybe even easier method. Please let me know. Okay. So I'm going to give you also a few more minutes. So did you find the LCD for this problem?
X minus 2.
Yeah, x minus 2, right? So we multiply x minus 2, everything here. Then this becomes x minus 2 times 3x plus 1 over x minus 2 plus 2 times x minus 2 equal to 9 over x minus 2 times x minus 2, right? I really hope you understand what we are doing. So cancel out all these common factors between numerator and denominator. Then this becomes 3x plus 1 plus, I'm going to distribute, then 2x minus 4 equal to 9 here. Okay. Now, can you combine like term? So as you see, those two are like terms, and then these two are like terms.
IX minus 3 equal 9.
Yeah, 5x minus 3 equal to 9, and plus 3. So 5x equal to 12. So you divide by 5, then x equal to 12 over 5. Okay. So that's the answer. And then also, in this case, even though you plug this into here, it wouldn't be 0, right? So we confirm that can be the answer. Okay, then I'm gonna give you a little bit harder one. So m, which is y over y plus 3 plus 2 over y squared plus 3y equal to 6 over y. And then one more questions. Hopefully I can fit it here. Y plus 2 over y squared minus y minus 6 over y squared minus 1 equal to 0. Okay. These two problems, please. Okay. So let's do the first problem. What is the LCD for first question here?
Y plus 3.
Yeah, so y and then, oops,
Parenthesis y plus 3.
y plus 3, right? Okay, so let's double check, because this becomes y over y plus 3 plus 2 over, factoring this one, and y plus 3 equal to 6 over y. Okay, so since it includes everything here, so y times y plus 3 will be the LCD here. Okay, now let's multiply LCD to everything. So y times y plus 3 times y over y plus 3 plus y times y plus 3 times 2 over y plus 3 equal to 6 over y times y plus 3 here. Okay, you can simplify from here, just do it. Supplement some step, that's why I'm showing all these steps anyway. So y plus 3 is gone, y plus 3 is gone, and then y and y is gone. Okay, then this becomes y
Y.
times y plus 2 equal to 6y plus 3 here. And now you know what y times y means, right? Y times y becomes
Y squared.
y squared. So y squared plus 2 equal to now 6y plus 18. Okay. So now it looks like quadratic equation. So I'm gonna move every term to the side where our leading term is located. So I'm gonna subtract 6y, then subtract 18, and this is gone here. So y squared minus 6y plus 2 minus 18 equal to 0. We combine like term, then y squared minus 6y minus 16, yeah, equal to 0. Okay, now this is a quadratic equation totally. So now we're factoring negative 16, negative 6. What are two numbers? You multiply them, negative 16. The sum becomes negative,
2, 8.
yeah, 2 and 8. So between 2 and 8, which one must be negative sign?
8.
Or 8. Okay, so this becomes y minus 8, y plus 2 equal to 0. Okay, so from here, because we are finding our equation, so y minus 8 equal to 0, y plus 2 equal to 0. And you combine 8 here. So y equal to 8, subtract 2, so y equals negative 2. So far we got y equal to 8 and then y equal to negative 2. But before you circle like this, we have to go back. Because one of these factor may make denominator equal to 0. So between y equal to 8, negative 2, 8 and then negative 2. Thus any number makes one of these factor equal to 0. You know what I'm talking about? Why I pause for a second and then double check. This value make this factor equal to 0. And then which one makes equal to 0? Okay, if you plug 8 times 8 plus 3, does it become 0? No, right? Okay, what about negative 2 then? Negative 2 times negative 2 plus 3, not equal to 0. So now we can confirm that they both are the answers. Because sometimes finding answer that may make denominator factor equal to 0, then we have to omit that. Okay, so that's the reason. Now, these questions. What's the LCD for these problems?
Y minus 1.
So y,
Parenthesis y minus 1.
y minus 1. That's it?
Yeah, I think so.
Okay, so let's double check. So factoring this place, if you're factoring denominator factor here, then it becomes y plus 2 over y minus 1, right? And minus, now 6 over y squared minus 1. If you factor out, then what does come out?
Y plus 1 times y minus.
Yeah, y plus 1 times y minus 1. Okay, so when I see this one, it doesn't cover y plus 1. So you need to put one more y plus 1 as well. Okay, so that can be our least common denominator. Now we multiply that here. So we multiply y minus 1, and y plus 1 into this expression. Then this becomes y minus 1, y plus 1 times y plus 2 over y minus 1 minus 6 over y plus 1, y minus 1 times y minus 1, y plus 1 equal to 0, because 0 time all these common denominator becomes 0, so I'm not going to do anything. Is it okay with you? So here I supposed to multiply y plus 1, y minus 1 as well, but 0 times this will be 0, so I don't do anything. Okay? Okay, then this become, and then here. So therefore, it will be y plus 1, y plus 2 minus 6y equal to 0. Okay, so now we need to expand, and then we're factoring out again. So then y squared plus 2y plus y plus 2 minus 6y equal to 0. So combine like term, then y squared plus 3y, no, actually all this together, then minus 3y plus 2 equal to 0. So now let's do factoring, then multiply them by 2, sum become negative 3. What are two numbers?
2 and 1.
4 and 1? What do you say
2,
again?
3 and 1.
Yeah, 2 and 1, right? 2 and 1. So both are negative here. So become y minus 2, y minus 1 equal to 0. So from here we found out y minus 2 equal to 0, y minus 1 equal to 0. So y, so combine 2, then y equals 2, plus 1, then y equal to 1 here. So we found 2x value here, 2y value here. So I'm gonna go bring up here. So we found y equal to 2 and then 1. Does any answer make one of these factor equal to 0? Do you know what I'm talking about? So far we found two answers, y equal 2 and then 1 here. Now we want to double check. These answers don't make denominator factor equal to 0.
Okay, number 1.
Yeah, unfortunately, number 1, this one makes that equal to 0, right? So even though we did hard work and find the answer, the only answer is y equals 2. Okay? So like this, when you do rational equation, you always find out which answer may make denominator factor equal to 0. And then if it does, then you must omit it. Okay? So any questions? Okay, then I'm gonna assign about 15 minutes. So you kind of solve the question with your classmate. So chapter 3, page 27, we're gonna do P, Q, R. Right, so I'm gonna give 15 minutes. I mean, if you have any question, feel free to ask your classmate. Okay, so let's start reviewing the question together. So what should be the first step to solve this problem?
Factoring first.
Yeah, factoring denominator, right? So
Mhm.
this becomes 2x minus 3 over what?
2, yeah, 5 multiplied with x plus 2.
So 5 times x plus 2 plus, so 3x minus 2 over, so factoring
Plus 2.
denominator,
4 plus 2.
yeah, 4x plus 2 equal to 1. Okay, what's the LCD for this case?
X plus 2.
There's a common factor here. We are finding common multiple between two denominators.
Is it 20 multiplied with x plus 2?
So 20 multiply x plus 2. Okay. Okay, so far, if you don't understand why we got 20 times x plus 2, just let us know so we can go over. Okay, then we multiply LCD to every expression. Then, so 20 times x plus, so 20 times x plus 2 times 2x minus 3 over 5 times x plus 2 plus 20 times x plus 2 times 3x minus 2 over 4 times x plus 2 equal to 20 times x plus 2 times 1. Okay, so now this is gone. What will be 20 over 5?
Or
4.
4. Okay, so this becomes 4. What about 20 divided by 4?
5.
5. Okay, so this one just as is. So this becomes 4 times 2x minus 3 plus 5 times 3x minus 2 equal to 20 times x plus 2. Okay, please double check you have that so far. So 4 times 2x minus 3 plus 5 times 3x minus 2 equal to 20 times x plus 2. Now we open the parentheses, let's distribute. Then 8x minus 12 plus 15x minus 10 equal to 20x plus 40. So I'm going to combine the like terms. Then what do you get? I can say 23x minus
Yeah.
22 equal to 20x plus 40. Now I want to gather x value to the left side, numbers to the right side, minus 20x. Then 3x equal to 62. Make sense? So double check whether I make any mistake. Did you get 3x equals 62 as well?
You only need minus 20x.
Yeah, so I substitute minus 20x here. So 23x minus 20x becomes 3x. Now I also do plus 22 on the both sides, so it becomes 62. Okay, anyway, if you get
Yeah.
different answer as I have, then okay. So I got x equal to 62 over 3. Now I double check. This one makes, it doesn't make this equal to 0, so I can say that's the answer. What do you think? So let's go over one more time. So 4 times 2x minus 3 plus 5 times 3x minus 2 equal to 20 times x plus 2. So I distribute. So 8x minus 12 plus 15x minus 10 equal 20x plus 40. I think so far I don't make any mistake. And then combine like terms, 8x and 15x. So 23x minus 22 equal to 20x plus 40. I think this is the answer. What do you think?
Me too.
You too? Okay, that's good. Okay. And now, next one here. So this one, we also need to do factoring. Okay, so this becomes 4 over y minus 2, the prime factor, minus 2 over y prime factor. What about third one? If you're factoring out, so y squared minus 2y, so if you're factoring out, so y times y minus 2, right?
Yeah.
Yes, what's the LCD?
Y times y minus 2
Yes, y times y minus 2. Okay, then,
times
so y times y minus 2 times 4 over y minus 2 equal to minus y times y minus 2 times 2 over y equal to 3 minus y over y minus 2 times y minus 2. So we cancel all these common term between numerator and denominator. Then it becomes like this. So this becomes 4y. So 4y minus 2 times y minus 2 equal to 3 minus y. Okay. Now you distribute. Then 4y minus 2y plus 4. Don't forget this plus 4 because you are multiplying by negative sign here. So 3 minus y. So combine like terms. Then this becomes 2y plus 4 equal to 3 minus y. As I
Can you
did,
move over the screen to the left?
4 variable on the left side, number on the right side.
Professor,
Plus y, yes.
the screen is cut off to the left. Can you move to the
You cannot see this?
all the way to the left of it? Or is it your right?
So can you see my work or not? That's more important.
That's what I'm trying to see. I see up to 4y. I see what you're doing now.
Yeah, because of this one is already.
Oh, something else? Oh.
Now the second question, so that's why I'm
Oh.
keeping this on screen now. So, and minus 4, then, so 3y equal to negative 1. Now divide by 3, so y becomes negative 1/3, and then I'm gonna go back up and double check y equal to negative 1/3 makes one of these equal to 0, and it is not. That's why I can say that's our answer for these problems. Okay. And third equation here, number 3. So we need to factor out first. So this becomes 2y minus 2 over y plus 3 minus 18 over what? Y squared minus 9 becomes
What is-
factoring. It should be y plus 3, y minus 3 equal to y minus 6 over y minus 3 times, yeah, like that. So what's the LCD for this case? LCD must be this one. Now we multiply LCD to every expression. So y plus 3, y minus 3 times 2y minus 2 over y plus 3 minus y plus 3, y minus 3 times 18 over y plus 3, y minus 3 equal to y minus 6 over y minus 3 times y plus 3, y minus 3. Okay. Then now I can see this is gone and all this is gone. Okay. And this becomes y minus 3 times 2y minus 2 minus 18 equal to y minus 6 times y plus 3 here. Okay. Now we need to expand and then refactoring again. So this becomes 2y squared minus 2y minus 6y plus 6 minus 18 equal to y squared plus 3y minus 6y minus 18. Okay. Now I'm going to combine all the like terms, each side first, each side. So I can see those two are like terms and these two are like terms. And then these two like terms. Okay. Simplify, then 2y squared minus 8y minus 12 equal to y squared minus 3y minus 18. Okay. So leading terms on the both sides here, but between 2y squared, y squared, which one has the bigger value? Between y squared and the y squared, which one has the bigger value?
2.
The 2y squared. So I'm gonna get everything where the bigger number located. So minus y squared plus 3y plus 18. Then this is gone. So that becomes y squared minus 5y plus 6 equal to 0. Am I calculating correctly?
Mm-hmm.
Okay. And now we're factoring out. So you multiply two numbers become 6. The sum become negative 5. What are they?
1 and 6.
4 and 6?
1.
1 and 6. Okay, 1 and 6. Okay. But in this case, 6 plus 1 is not negative 5 though, because this is a positive number, which means they must both have negative sign, but negative 6 times negative 1 is negative 7. So it doesn't work.
So 5 and 1.
So 5 times
Is
1,
it 1 and negative 6?
what do you say?
1 and -6.
No, then it become plus 5.
And 1.
This become plus 5. So you multiply two number, it must be positive 6. So what times what become positive 6, but their sum become negative 5.
2 and 3.
Well, or we can just -6 and 1, +1.
No, negative 6 times 1 become negative 6. It is not same as positive 6.
-3 and -2.
-3 and -2. Yeah.
Negative 2. Yeah, I agree. Because of negative 3 times negative 2 become positive 6. The sum become negative 5. So it becomes
Yes.
y minus 3, y minus 2 equals 0. So y minus 3 equals to 0, y minus 2 equal to 0. So y equals 3 or y equals 2. Yeah, we get the two answers, but before you circle them, go back. Go back. So y equals 2 and then y equals 3. Does any y makes one of these factors equal to 0?
Yeah.
Number 3.
Yeah, unfortunately, it cannot be the answer. Therefore, our final answer, y equals 2 only.
Okay, so you, by that you mean if any of these solution makes one of the denominators 0, that means it's not the answer.
Exactly, yes.
Okay.
Because any answer makes denominator factor equal to 0, then it represents undefined case.
Exactly.
Yeah.
Okay.
Okay. All right then. So just give me a second and then so explore this graph y equal to 1 over x and then just let me know whatever you see that. Okay. So I'm gonna zoom out a little bit so that you can see a little better. Okay. So that's the graph. And then what do you see?
The value never get to 0.
What does that mean?
Then because x is in the denominator, so it can't be a 0.
Yeah, so on the graph, how can you explain that? So actually, Osama just made a great point of this graph, I mean this function. He just said that x cannot be 0. Now we want to interpret how we can interpret that graphically. So on this graph, we know that x equals 0 will be undefined, but graphical way, how can we describe it?
Can say all values can be, as long as it's not 0. It can plug in that function except 0.
Yeah, you're totally correct. But what I'm saying is how to interpret it graphically. So we totally understand x cannot be 0. If x equals 0, this is undefined case, right? And then I brought it out this graph, y equal to 1 over x graph here. So using this graph, how to define x equals 0 case. So what's happening on this graph here? You know what I'm talking about?
The two curves, one curve is just goes in the positive numbers, and the other curve just goes in the negative numbers. So it can be in both ways.
Okay, so I just interpret what Osama just mentioned. So we see that y equal to 1 over x graph looks like this. So we just find out graph looks like this, right? Make sense? So let's double check. See? So now Osama just mentioned that x equals 0 makes undefined case. Now we want to interpret it graphically here. And then if I remember correctly, on the left-hand side, it going to negative side. On positive side, it going to positive side. Is that right? Osama?
Mhm. Yes.
Okay. Do you understand what he's saying? Yeah. So I hope quiet means positive sign. So this is x equals 0, right? This is the x equals 0 here. Based on that, as you see, graph going to forever, like vertically. And then on negative side, going down to forever, basically. Okay. So that's the typical y equal to 1 over x graph. And now here, in this case, at x equal to 0 lines, it never across the x equal to 0. Instead, it kind of increase or decrease dramatically. So this line we always call vertical asymptote. Okay. Again, what does the vertical asymptote means?
That means x values never intercept with the 0 line.
Yeah, basically the graph, the function graph never across this line. Okay. All right then. Can you guess vertical asymptote for y equal to 1 over x minus 1? Just guess what can be.
It will be instead of x equaling 0, instead of just being x, it will start at -1 instead, and x's never cross -1. The
What
line
about
of
positive
-1.
one? Positive one.
Positive one?
Positive.
Negative one? Okay, then let's check. So as you see, this is the 1 over x minus 1 graph. What do you see here?
It's never crossed the positive one.
Yeah, it never crossed the positive one here, right? You see that? Then what about I switch this to plus 1 then?
Then it never crosses -1.
Oh, let's double check. Yeah, you're right, right? So it's like, last time we talked about function transformation, and then whenever it's inside, then it always shift right or left. The same situation here. So whenever I put negative sign, then 1 over x graph moving to the right side. How much? This much, right? So which means if I can make -3, then what happened?
It doesn't go past +3.
Yes,
Positive unit.
like this, right? It never pass x equals 3 line here. In other words, 1 over x graph moving 1, 2, 3 is the right side. Make sense? Okay. Then now, what about I'm gonna make the bottom is x squared. Can you guess what's going to be then? X squared. If I put x squared, it becomes like this. Okay.
Professor,
Yeah.
Mamadou is texting me. He's having trouble logging into the session.
Oh, okay. Then let me give you the session number. Okay, so
20097.
why I'm contacting him just to discuss about that soon. Okay, so now can you find out what's difference between y equal 1 over x graph and then y equal to 1 over x square graph? So I can show both of them here. So red one describe y equal to 1 over x square graph, and then blue one describe y equal to 1 over x graph.
It doesn't go past the zeros on both sides when it's squared. It doesn't go past the zero on x and y.
Yeah, exactly right. So y square graph it never across that the bottom, right?
Yeah.
But if 1 over x graph, it kind of having here and here basically.
Yeah.
Okay, then can you guess? What if I make this is the 1 over x y
Squared.
cube? Can you guess?
Only stays in one graph.
Can I go to the other side?
So I'm gonna put here. Oop, what happened? What happened? So blue one is the 1 over x graph. Green one is 1 over x cube graph, right? So even though they look a little bit different though, but we can say basic shape is kind of same as 1 over x graph. Do you know what I'm talking about? Yeah.
Mm-hmm.
What about 1 over x to the fourth power? Good. Then it looks like here. I'm gonna zoom in a little bit so that you can see better.
It's like x squared, just closer.
Yeah, right. It can
Yeah.
be closer, but still looks like x square graph here. So based on that, the key point is if we have y equal to 1 over x to the n power, if n is odd, the basic graph looks like this, no matter what.
Yeah.
But if n is even,
It doesn't cross the y and
yeah,
the x and
then
stuff.
it looks like here, like this. Okay. How interesting it is. Makes sense to you?
Yeah.
Yeah. Okay. So now, so if I give you a little bit tougher one, y equal to maybe 1 over x plus 2 square, maybe minus 2. Then how can you guess this graph? You actually, only this one first.
Since it's squared, we know that it doesn't go past the x-intercept line.
Mhm.
And since plus 2, it starts at negative. It doesn't go past -2.
Okay, so as like Mohammed just mentioned, the original shape is like this. But
Yeah.
now moving to the 2 units left here,
Yeah.
it becomes our new vertical asymptote, and then this becomes like this. Okay, then now, can you guess y equal to 1 over x cubed plus 1?
It's the other shape and it starts at -1. But it's
So
closer in.
1 over
It's the
x
other
cubed
shape.
plus 1.
It's the other shape, but it's closer in to 0, and it starts at -1.
What
Never
about positive one?
positive 1.
Yeah. Because it's not with the x at.
Basically, there's nothing moving here, right? So
Yeah,
I
so the
guess
u
this
will be
must
on the y
based,
side.
yeah, based on this, right? Still based on this.
Mhm.
Now we figure out plus 1 value here, plus 1. So this plus 1,
Gonna be in the one axis and the y axis.
and so how can you guess this graph though?
It's never get close to the one on the y-axis.
Y-axis?
Yeah,
This is the y-axis, right?
yeah.
But
So
last time,
positive one.
okay, then how can you explain this one then? Y equal to 1 over x minus 1 to the cubic.
That one, the vertical centers. I don't know what do you call it.
Yeah, body asymptote,
Will
yes.
be on the axis. Yeah, it's gonna be on the x-axis. But if we have the number not next to the
Oh,
x,
okay,
so
now
it's
I
gonna
know
be
what
on the
you mean. I know
y-axis.
what you mean. So this means on the y-axis, it doesn't pass through here. That's what you mean, right?
Yeah.
Okay, so should be going up one value basically like that. Okay, let's double check here. Yeah, you're right. So as you see, 1 over x cubed plus 1, it still have the vertic asymptote x equals 0, but it never passing through y equal 1 either, right? Okay, then, oh, you see my screen?
No.
Maybe not. Okay, so as you see this graph, now are you seeing my graph?
Mm-hmm.
Okay, so 1 over x cubed plus 1. So we have exactly same vertical asymptote, which is, I'm gonna a little bit zoom out so you can see better. See? So as you see, it never across that x-axis and y-axis here, which is x equals 0. It also never crossed that, y equal to 1, the line here. Okay, so like this. So now I can maybe make a little bit harder one, such as 1 over x plus 1 square plus 2. Then we always begin from, maybe you're gonna see. So we always begin from this graph. And then how can we guess this one's graph?
Because
It
of the
says
power.
squared. Yeah. You start from that position, and it says squared, so it stays like that. No, it's squared, so the position flip, yeah, stays like that. Plus 1 means that I will start at -1 because it's under the 1. It's in the fraction. So it'll
Okay.
start at -1. The zeros, it doesn't pass -1.
Mm-hmm.
And plus 2 will be the direction of the y. So it will start at +2.
Great point. So here, like Mohammed just mentioned that, opposite this one is direction to x, this is the direction to y. So we are making, and the opposite this one become our new vertical asymptote, which is -1. And then this is our new horizontal asymptote. I'm mentioning for the first time, but I'm going to explain what that means more detail later. So they become our new horizontal asymptote. And then our graph looks like here. Okay. So as you see, this red highlight graph here, it never passing through this line, which is x equal -1. So that will be our new vertical asymptote. And now it never passing through y equal 2 here. So that line we always call horizontal asymptote. Okay. Then based on that, now I'm gonna go back to here. So at the beginning, when we look at this graph here, now we only focus on talking about vertical asymptote, but now we also have the horizontal asymptote, which is y equals 0 here in this case. So as you see, it never, if I zoom out more and more, it never across the y equals 0 line either. So x equals 0 become vertical asymptote, y equals 0 become horizontal asymptote basically. Even this one too. I mean, so like that, it never across that y equals 0 either. So still vertical asymptote x equals 0, horizontal asymptote become y equals 0 basically. Okay.
Yeah.
Yeah. So basically we cover so until 3.7,
No, right now.
3.8.
Yeah.
So now I'm gonna give you time to practice page 35. So C, and B is good question. B we haven't covered that. Letter B anyway. So try B and C, please. Okay, B and C. So page 35C is gx equal to 1 over x plus 4 plus 1, right? Okay. So who can just explain the parent function? Where should we start first? Anyone want to explain?
I was speaking, but my mic was muted. I said since it was x plus 4, I started at -4
Mm-hmm.
with the function with the graphing uses the ones facing the opposite of each other because it's not squared.
Mm-hmm. Yeah.
And for the +1, I started the function at +1. So
Yeah. So
I started at +1. So it's yeah, facing
we
away
can,
at each other.
so we can make a new vertical asymptote which is
-4
-4.
and horizontal 1, which is 1.
1 here. And then graph will be this shape, right?
Yeah,
Makes sense?
yeah.
Okay. Now, B is really hard actually. B shows that 5 minus 1 over x squared. Okay. So this makes total different function here. The minus 1 over x squared. Okay. So I'm gonna give you 1 over x graph first. So 1 over x graph become like this. Can you guess minus 1 over x square graph?
Flip
The
it.
opposite, inverse.
How? So
So it goes in the minus way, the negative side.
okay, basically we flip based on x-axis, right?
Yeah.
Yeah. This is the 1 over x square graph. Okay. And now, what does this mean?
That it will start at positive 5.
Mm-hmm.
So even though it's flipped, you moved to the top of positive 5.
Yeah.
So the horizontal line would be at positive 5, and you just
Okay.
flip the graph.
So 1, 2, 3, 4, 5. That's our new horizontal asymptote. And then now we put this graph basically because this is minus 1 over x square graph. So answer
Yeah.
becomes looks like this. Make sense?
Yep.
Okay, so I'm gonna call that's all today, and then I'm gonna just begin at the section 3.7 tomorrow. I don't know, Wednesday a little bit, and then
All right.
hopefully we can move up to the lesson chapter 4. But anyway, I really wanna end chapter 3 on this Wednesday. And about the midterm, so the testing committee almost end, right? The take-home midterm exam. So we're gonna let you know really soon. But please watch out because that's the exam, so I cannot give you longer than 2 days. So I may limit only 2 days and then ask you to submit on the blackboard. So please watch out my announcement all the time. Good. I also want to make an announcement about it maybe this coming Wednesday or Thursday, so you know what is going on soon. Good?
All right.
All right, then have a good day, and then I will see you this.
Professor, I have a question.
Yeah.
About the vertex
Mhm.
videos. You didn't have any videos for the vertex class.
Okay, then just describe a little more details, so send me so I can find it for you.
Okay, thank you.
Okay, all right. Any other questions? All right, otherwise, I will see you this coming Wednesday.
Sure.
Okay, bye.
Bye.
Bye.